Hello everyone, my name is Espik23 here for a KTaNE module tutorial. In this tutorial we're going to be covering the Encrypted dice module. Now, this module is actually based off of a video by a fellow community member TiMWe that he made as a solution to the 3 indistinguishable dice problem by Stand Up Math. And this manual follows the same rules as the flowchart that TiMWe provided in his video. So if you know that flowchart or have seen that video, this module works exactly the same way. But for those of you who don't, I'm going to explain it right now. Let's look at this one. So this is what the module looks like. It has a set of 3 dice on the top, a set of 2 dice on the bottom. You can change the values of these 2 dice on the bottom, but not these top ones. And this roll dice button. We're not going to press this button just yet, and I'll explain in a bit. So what we've done is 3 dice get rolled, and you have to take the 3 values and convert them into 2 values for these other dice to submit. And to submit our answer, we roll the dice again. The first roll is done for you when the room's lights turn on, which is why you heard a ton of dice rolling when the bomb started. So that's why we don't press this again, otherwise it'll probably strike us. Actually, will strike us. I know this is incorrect. So what this manual says to do is to take the top 3 values right here and write them as A, B, and C. So the top 3 values are 5, 1, and 3. However, we're actually supposed to be sorting these from smallest to largest. So we actually have 1, 3, 5. X and Y are going to be the values that we submit in any order. So for example, let's say if the answer was 3, 4. I could submit 3, 4 or 4, 3. I know that's not the answer for this one, but you know. Just a clarification, the dice that you submit is in any order, but for the sake of this manual right here, A, B, and C have to be sorted smallest to largest. So, let's get started with these rules here. So, if A equals B and A equals C, that's not true. If A equals B or B equals C, nope. If C equals 6, nope. If C equals 5 and B minus A equals 1. Well, C does equal 5, but B minus A is 2, not 1, so no. If C equals 5, yes it is. So X is A plus B, and Y is 6. So A plus B, 1 plus 3 is 4, it already says, and Y is 6. So we have 4 and 6, and we submit by rolling again. There we go. That's 1 out of 3 stages complete. Now we have 1, 2, and 4. A equals B and A equals C, nope. A equals B or B equals C, nope. C equals 6, nope. C equals 5 and B minus A equals 1, nope. C equals 5, nope. Otherwise. So X equals Y, and Y equals value from 1 to 4 not present. So as you've noticed, we have 1, 2, and 4, and there is a value from 1 to 4 that's not present, which is 3. So X is Y, and Y is 3, so X is also 3. So we submit 3 and 3. There we go. And finally we have 1, 6, and 6. A equals B and A equals C, nope. A equals B or B equals C, well B does equal C, so yes, X equals A and Y equals C. So X is now 1, and C equals 6. And there you go, that's a solved module. So, that was how the module works. It's quite easy. Here's another one. We're going to go through all these rules in order, and I'm actually going to kind of clarify what they're actually talking about in words rather than equations, so if that can help. So, for this module we have 2, 4, and 6, but I'm going to explain these rules quickly first. Get some more water. So, A equals B and A equals C. This is basically asking if all 3 values are the same. So if I had 3, 3, and 3, or 5, 5, and 5, all 3 values are the same. X is 5 and Y is 5. So whatever number is the 3 of a kind, we submit 5 and 5. A equals B or B equals C. Excuse me. This is basically asking if there are only 2 distinct values. So 1, 2, and 2, or 4, 4, and 3. Or actually, that wouldn't be in that order. Or 3, 3, and 4. Let's do that. Since in those two cases, there's only 2 different values being used, 2 instances of one value and 1 instance of another, we submit those 2 values. So in this case, 3, 3, 4, we would submit 3 and 4. Or 5, 6, 6, we submit 5 and 6. So if there's only 2 values present, submit the 2 values. Then C equals 6, basically saying, is there a 6? There's actually this rule right here, 2, 4, 6. X is A and Y is B. So basically, if there is a 6, we submit the other 2 values, 2 and 4. Or 4 and 2, doesn't matter. Anyway, I'm going to go through that. Then we have if C equals 5 and B minus A equals 1. So that would be something like this. So, what this is saying is, for B and A, we submit A, which is the lowest value of the 2, since we're sorting from smallest to largest, and also submit 6. So this 5 turns into a 6, and we submit the lower value of the other 2 dice. Also works with 1, 2, 5. The 5 turns into a 6, and we submit the lower of these 2 values, which is 1. Excuse me. So the next case is C equals 5, but B minus A does not equal 1. Then we submit A plus B and 6. So 5 still turns into 6. However, instead of just submitting the lowest value, we submit the sum of the 2 values. So 1, 3, 5, we would submit 4 and 6. Also, if you had 2, 4, 5, you would submit 6 and 6. Finally, with this otherwise case, which you added to on this module down here, there's actually only 4 different combinations of dice that will lead to the otherwise case, which are 1, 2, and 3, 1, 2, and 4, 1, 3, and 4, and 2, 3, and 4. In all 4 of these cases, there is always a value from 1 to 4 not present. And you basically submit that number twice, so 2 of that number. So 1, 2, 3, you submit 4, 4. 1, 3, 4, you submit 2, 2. 1, 2, 4, you submit 3, 3. And 2, 3, 4, you submit 1, 1. Kind of did those out of order, I didn't realize that, but there we go. But you get the idea. It's written a little bit weirdly, but I guess this was for formatting. Actually, it was for formatting. I can tell you flat out because I actually made this module. Whoops. So let's continue solving the rest of this module. So we have 6, 6, and 4, or 4, 6, and 6. That's going to be this case. We just submit the 2 values that we see. 6, 5, and 6, same case. So here's an interesting thing. When you solve this module, it actually rolls the dice again. Now, you can actually keep pressing this button, but the thing is, you actually can play around with this module if you want. So for example, if I submit the wrong answer, the correct answer is 4 and 5. If I submit the wrong answer, the lights will turn red. That normally happens when you get a strike. However, the module won't actually strike. As you can see, this bomb only has 1 strike, which is from this module. So you can essentially, once this is solved, you have nothing else to do. You can actually just play with this module if you want, and mess around, do whatever. And if you're actually kind of learning to memorize this table, you can kind of test to make sure that you're right or wrong or not. Or unlike if the module's not solved yet, let's say if I wanted to submit this, that would be 2 and 6. And as you can see, the lights do turn red according to how many stages you completed. This is a little minor detail, but this is 2 and 4. And this is 2 and 5. So that's the case, and I also know this is 4 and 4, so this module as well also works that even if you solve it, it'll still tell you if you're correct or not, but it will not get strikes as long as it's solved. So yeah. But also, yeah, another thing I mentioned earlier is that almost 4 years ago now, Tim Wee made a video on YouTube, which I'll show you right now, giving a solution to 3 indistinguishable dice problem by Stand Up Math. and he made a flowchart consistent of what you roll and what you should treat it as, because they're using the same case as the module, which is converting vibes from 3 dice to 2 dice. The flowchart works exactly the same, so you can use this flowchart if you want, or you can use this table, it doesn't matter. But anyway, thank you guys for watching this tutorial, and as always, keep talking and don't explode.